Alright, and we are live then. Welcome back. We kind of stopped, well, sort of a month ago and never came back to this, but yeah. Well, I started a little bit earlier too, about half an hour earlier, because I was afraid I wouldn't be able to get through all of it. Well, so where we stopped last time? If you recall, if you were there last time, what, on my May 30th stream, I think, yeah. You will recall that I was getting, well, the amplification wasn't going too well, mostly because I was getting some weird, well, some weird effect with the amplification. Turns out, well, it wasn't anything weird at all. It was just that I was a bit of a dumbass and just forgot completely that you're supposed to put a common mode voltage in both poles. So yeah, I have the circuit over here. I'll just show it real quick. I have the circuit over here with the two. Well, this amplifier is new. I will explain what it does in a second, but I had to modify this one slightly, which would be going back to the schematic, the U question mark B. And well, let's see. Right, so what did we do? What did I do? Well, I had to do some, actually, I could have gotten away with doing a simulation, but, well, in the spirit of, you know, testing, it's not really, in the spirit of testing your own stuff on, it doesn't really make much sense to just run a simulation, especially since, well, you can run a test anytime, you can run a simulation anytime, and it might not even be that accurate. So, well, I had to debug it through with an oscilloscope. I will show what the outcome is in a bit. Just give me a second. All right, so this one, I forgot the controls. What was this? Yeah, mirror around that. Well, whatever. I'll just do it like this. So turn it around. I'm gonna do. No, hold on. Mirror around x-axis. Yeah, I'm gonna do it at an inverting. Yeah, but then I should really. I'll do an inverting configuration for this one. I will show in just a second what that means. Too. Right. So this thing moves up here. I'll delete the lines. This one too goes up there. Yeah, the ground can. I guess I'll move this ground up and just get another one later. So I actually may have done some other modification here, but I will check rigorously afterwards before uploading the schematic. Anyhow, this is gonna go, well, before uploading the schematic anyway, not afterwards. This is gonna go here. I don't actually need this ground here, so let's just put it back because we'll need it down below. Delete this, move the ground to the capacitor, and basically what we need to do is give the 2.5 volts here, which we sort of overlooked last time. Since we biased here to have the VDD, we're gonna have to bias this one too. We can't just take from here though, since well, it's gonna have the signal here, so it would just cancel out and get a 0. So what we have to do is get a new op amp, always an LM358 because that's what I have. We feed in, well, we put it in a perfect feedback. We put it in a unitary gain configuration. This is gonna feed over here, and we should be good. Now just add a VDD and just add a VDD. Yeah, this one's fine. two resistances, which I am... These I'm sure what they are. Which is 50 kilo ohms. And another ground. GND. Right. And that's pretty much what we gotta do to get this. We should be getting 2.5 volts now. And I'll show in just a second that that is the case. Well, 2.5, not quite, because this isn't a perfect 5-volt circuit. So where is my Arduino? Here it is. Right. So, yeah, I use the Arduino as power, as the power supply for this. So, and it does supply more than enough to get it running. So that's not much of a problem. I want to plug anything in now, but just to let the circuit run empty. Get my oscilloscope probes. This one goes on. Yeah, I should probably put it in a closer. Well, I mean, I could. They're both common ground, so I could just ground with this one and then just. Anyway, so we are looking for the voltage coming out of this amplifier. It should be 2.4 volts. And I think that disconnected it. Oh, god damn it. There we go. Right, where else can we, where could we put a probe in? Yeah, you know what? Yeah, we'll put the probe right here. And put the probe right there. Just connect it like, god damn it. Wow, it really doesn't want to go in. What is wrong with this wire? Oh. Alright, well, it should be in. So, connect it like so. And once we switch on the circuit, it should, where is here it is. The power cable. And well, let's get the, yeah, let's just plug it in as so. Boom, boom, boom. Oh wait, the desktop audio is muted, so I probably didn't hear it. So, and then we go into the oscilloscope program, and once we turn on enable the yellow channel. This is the yellow channel. Yes, this is the yellow channel. 1x magnification. So yeah, first probe x1 enable, and we are getting 500 millivolts per division. Oh, so 1 volt per division. Still nothing. Huh. Well, this didn't go as expected. So what's going on? Is this not Is this not connected properly? Huh? That's gonna have to go multimeter then. Oh, it does seem to be reading something, but I can't see what. Huh? Hold on, something moved. Yeah, it is reading something. That is 0 volts. So maybe I just need to drag the channel down. Yeah, there we go. That did the trick. So yeah, we are having here 2.4 volts, which is close enough to 2.5 that we can say it is halved. At least for this occasion, since we're probably receiving somewhere around 4.8 from the supply. And well, let's keep going then. Anyway, right. I think are we done with this? Yeah, we are done with modifying this. It's working now. I'll show you in a second, since yeah, I gotta plug this in. Don't mind the oversized aux cable. Sometimes it's I have no idea why, but sometimes it's cheaper. Well, it's what I got first, like at hand, and sometimes it is cheaper than the smaller cables for whatever reason. But anyways, yeah, let's give me some more cable so I can hide this rat's nest. And yeah, my little iPod, plug it in. Actually, does it have my name on it? No. All right, great. Then, well, we want to see the waveform that's coming out of it. So, once again, if we use this as a probe point, we can also monitor what's coming into it. This is a very bad. We can also monitor what's actually coming into the amplifier, and we should be able to do so right over here. Hopefully that doesn't disconnect anything, but we'll have to wait and see. Right, so turn on the amplifier, well, not the amplifier, turn on this. We're actually getting some noise. Anyhow, there's also going to be a 1x probe. Let's put 1 volt. Enable. Yeah, sounds about right. Yeah, it's 2.4 on both. So sounds about right. Actually, yeah. Anyway, no, I'm gonna want to put the trigger up and up. Since we don't really have a waveform to really lock into, so we can just leave the triggers down. Anyway, so let's go. Yeah, let's just put something here. Not like I will. Not like you'll be able to hear, anyways. At least without me getting a copyright strike. So, I mean, let's play a game. Let's see if you can guess what it's playing from the waveform. Oh man, yeah, I really need to change the battery on this. It's really draining fast. Right, so it should also already be calibrated for whatever gain it's receiving, though apparently not. So I'm gonna have to get my screwdriver and should be a Philips 00 in theory, yeah. And yeah, you can't really see much on the input side, but there will be a signal on the output. Hopefully. Yeah, this is max whack. Turn up the volume. Oh, there we go. Yeah. Now it's saturating all over the place though. So we want to turn it down a bit. Cause saturation ain't good. I mean, not like it's connected to anything, but this should be enough for now, cause now we gotta do something before we actually move on. Cause to make the program, like the program we actually want to do work, we need to measure what is the minimum and maximum it can reach. Well, I mean, we could also look at the data sheet, but actually, yeah, I want to check what top. Yeah, it tops up at 3.7 volts. And does middle do anything? 1.86. Not really. In channel 2, let's see the middle for channel 2. 1.30. Yeah, it doesn't really make much sense, does it? Yeah, well, the maximum volt here is 2.6, so you can assume that it's going to be from 2.4 to 3.7. Somewhat the amplitude. So with that in mind, we can go. Well, let's just write it down real quick. All right. Four, 2, 3.7 volts. Yes, the part that actually matters. So we come over here, we already have this LM358, so LM358, I want the unit B. Come over here, have the same setup as here, except we're gonna need the to calculate what resistances we want to get the 3.7 volts for reference. This one I could put just a line like this, label it 8F. There we go. Yeah, so this one goes to AREF. Oh yeah, these ones were 50K and 50K. So, well, we want 3.7 volts. Let's say that we want the highest resistance to be 50K. So over there we have we will want to make a voltage divider. Oh, I will explain in a second why you put the operational amplifier before after the divider. In theory, the divider could also work, but the amplifier adds some stability to the signal. Anyway, so we want 3.7 volts at the output. The equation would be 3.7 equals 5 times the lowest R2 divided by R2 plus R1. R2 being the lowest one. Let's just make a drawing here. VDD R1, R2, and ground. So yeah, we already have R2 as 50K. We've set it as 50K ohms because we can't really find two variables from one equation, so we have to make do. Anyways, so well, 3.7 divided by 5 equals R2 plus R1. This is pretty well basic. I'm gonna use a calculator anyway because time is valuable, and you don't really want to waste time on stuff that can be automated, do you? Divided by 5, so we have, well, it's gonna be 0.74 equals, well, R2 equals 0.74 R2 plus 0.74 R1, which means 0.26 R2 is equal to 0.74 R1. So R1 is R1 should be 0.35 R2. Sounds a bit low, but well, let's see. So 50k times 0.35 would be around 17k ohms. Do I have 17k ohms? Or else we'll have to bump up a bit. Well, let's see. Well, I will have 15k, which should bring the max voltage up a little bit, but it's fine. Yeah, so let me see, 15k, here we are. And I also got 50k, 51k, since that's what we need. I'll put the baggies over here. And anyways, so here are the resistances. In case this is your first time watching and you're not familiar with them, here they are. And well, we have 15k, we have 51k, so we have to put them in the form of a divider. And well, let's go. But I won't do much good if we don't know where to put them. So, got the data sheet right here. And here we are. It's gonna be this. We already populated the first op amp in the package, so we're going for the second one. So voltage goes in on the plus side. Yeah, let me first disconnect the power since I don't want stuff blowing up. Disconnect the power. The iPod should still be playing, but whatever. Let me unplug it too. So, as we can see here, we need to go from first from VDD to 15k. So, pick this up. And in plus into plus should be pin number 5. So this one over here. Then we got the 50k. Go from here to ground. And that's pretty much it. Then we got some wire, add the feedback in. I do use loose wire since jumpers are a bit too bulky for this. I mean, we just really need a tiny strip, so might as well just use a might as well just cut a tiny jumper. Well, a tiny piece of wire. Because then we want to connect pin number 7 to pin number 6. From here, out 2 to input 2 minus. So we can actually get the feedback. And then we want to also plug the output into the analog reference point in the Arduino. Hold on a second while I... Alright, so pin number 6 to pin number 7 should be this to this. So tiny. And there we go. And now this goes into the analog reference on the Arduino. Let me get a jump. For this I'll use a jumper actually, since it's a pretty big yeah, this one. And yeah, this might not be enough actually. Oh damn. Yeah, this won't be enough. I'll just do a... I should have gotten a piece of wire for this one too, since it's way too long, but, well, we can always do a hop. ARAF should be... IORAF. Yeah. I will leave it disconnected for now though, since... Wait a minute. Oh no, ARAF is over here. Yeah. I will leave it disconnected for now because we first need to program it to accept ARAF instead of just shorting out the circuit. And anyway, so... Well, for this, the at least as to what regarding hardware, the circuit is done, which is great. So we must move on to the software side. We have here the schematic for the previous part. Well, not the schematic, the code that we did on the previous part. Let me open up on the screen. There we go. Hopefully it's visible. Yeah, I don't really have much of a... Anyway, so just to test that it's working actually, before we do anything else. The ARAF still isn't being read, so we will get a low value, but nonetheless we should be getting some reading on the... This is programmed to read analog 14, so we will connect the output to analog 14. Why I chose 14 doesn't really matter. Just choose whatever number you like the most, really. At least for this case. Right, so it's paused. Yeah, you know what? I'll show it. I will show it afterwards. So first I need to program this in. Upload sketch, yes. Alright. As always, I always use the LED pin on the Arduino to see if it's working. There it is. And well, let's play and see what... Well, first let's configure the serial monitor. Serial monitor. Here we go. Serial monitor. Connect COM3 115200. Baud. And now we're getting a reading. Yeah, we are already getting a reading. It's going sort of up and down since it doesn't really... If we lower the volume, it should... Hold on, let me take some stuff off of here and press this down so it actually makes some contact. I think this isn't making much contact. Oh. And the plotter isn't doing much. But yeah, looking at the... Well, what's going on then? Something happened. No, it's not the input impedance that's causing it, so... Ay. Right, probably have to mess with the gain once again. Yeah, this is already max gain, so... Something has gone wrong, I guess. Let me check real quick the connections. I can probably disconnect this one too. Everything has gone to 0. Interesting. Very interesting. What in the world is going on? Right, let's check. Let's do a check then. Well, this one isn't connected anymore, so... But it should be... Once I plug this in here, it should be getting something, which it isn't. And that's weird. No, it doesn't do much. And okay, so, we'll check that this is actually making contact. Oh, why is this here? Yeah, I should probably use those the jumpers for power. Doesn't seem like they're too reliable. The wires are too reliable on their Arduino. Oh, it should be getting 5 volts and should be connected to ground. Unless there's something disconnected, but there doesn't seem to be something disconnected. Well, except to this, but... You know what? Hold on, let me change cables. Right, so this one's going to 5 volts. Get out of here. You. And yeah, sorry if you can see the screen, but it's really, well, just me. Well, it's just me fiddling with cables, really. Trying to see why it's not chooching. Right, so this should be connected to ground. This should be connected to here. This isn't shorting, is it? Nope. Oh, maybe it is. Oh, but this is isolated, so it shouldn't really be a problem. Oh, right, the iPod's out of batteries. Well, guys, that's it for that. I'm gonna have to find something else to use as a media player, or else there isn't really much point, is there? Well, anyways, I'll put it to charge a second, and we'll get back to it. But for now, let's keep on programming. Yeah, I really need to change the battery on that thing. Anyways, so let's go back to programming. First things first. Yeah. On the setup, I want to actually use the analog reference. So first, during the setup, we put in here mode 13 output. Yeah, whatever. So, analog reference. External. So with this, we're already using the 3.8 volts that we should be getting on output. Well, in theory, anyways. And that should be it for at least this. Now we can connect. Well, next time we upload the program, we can connect it over. Is it well? Huh? Wait, what? What's this? Oh no! Could it be? Yeah. That's it, isn't it? Yeah, the amplifier lost its power supply. for unknown reasons, really. Oh no, did the pin break? Oh, I'm gonna have such a bad time taking it out later. Well, that's what I get, I guess. Yeah, now it's getting something. A lot of noise too. Is the iPod ready to go? Let's see. For somehow, yeah, probably for very little time. But well, let's go. Well, we have time. Hold on, I was playing something earlier, so it should still be music. Yeah, cover flow. No, I don't want. Well, yeah, let's just go with this. There we go. Now it's. Yeah, now we should be getting a better reading actually at the serial port. Yeah, there we go. That's more like it. Anyways, yes. Now this is good. So for the next part we disconnect this. No problem really. Save this. Actually we reconnect, upload. And then we can connect the analog reference in. A ref should be this one. Yeah. Or should it? 1098. Yeah. Ground. A ref. Oh, so there are two just empty pins, I guess. And well, yeah, the audio's going. So if we go on the serial monitor again, yeah, we are now actually reaching 1000. The plotter still doesn't work. I still haven't really gotten the. I haven't managed to get the plotter to work, honestly. So yeah, you can go. You see it reaches 1023, which is the maximum value. That's when it peaks, and I guess this is good. But this really won't do much for us, since we actually wanted to know the voltage and not the absolute value. Well, I mean, I guess it could be useful for us, but well, first things, we need to find what is the actual voltage that's going to the reference point. I'll use a jumper for that. Well, what is the voltage that's coming out of the reference? Let's find out. And once you go into the... Let me change camera again. We can see that it's actually at... What is this? Channel 2 maximum. 3.76. Yeah, that's fine. That's perfect, actually. Great, so we got 3.76. We can do some maths. Find out what's the how much of that would be 1024, then find out how much. Well, let's do some quick math then. So 3.76 is 1024. All right, so far so good. But we need to find how much is 2.4, because we want to find out what's the range of amplitude we got. So, well, once again, we gotta do a little bit of maths, really. 3.76. Well, no, hold on. All right. Jesus. So 2.4 is equal to 76x. Yeah, x equals, well, 2.4 divided by 3.76. There's really much of a mystery. So, hold on, something fell. Ah! It's my probe. Gotta be careful with them. Oh, look at. So, well, that would be around 0.63, so times 1024. 1023. We should be having a range from 652 to 653 to 978. That's our range of interest. So then, well, let's say for the purpose of what we are doing, we want to have like we want to find the peak of well, let's say 10 or so. We want to find the peak of 10 or so readings. So we gotta first introduce the where we begin. So then we first need to start an array here. So int no, what am I writing? Right, so an array of 20 elements named readings. Since we don't want it to update since we just want to get the maximum reading out of, well, let's say every 20 cycles. And then, well, every time we pass on the loop, if the condition where it's above 652 is met, it adds to the array. And well, let's add another variable, another constant variable here. And position 0. And there we go. So then, as soon as if well, reading bigger than 652, yeah, I think for C++ you had to do this, no? Giving me some sort of error. Syntax error. Yeah, I'm kind of rusty, so right. So yeah, that cleared it up. If reading is bigger than 652, we can write it into the array. No. Should be this, right? No, so it's probably the parentheses. Yeah, I'm a bit rusty with C. It's been a while since I last used C with C++. It's been a while since I last used it. Readings could not be resolved. What? But it's up there. Syntax error. Yeah, no, this is definitely not. No, this should be enough. Then readings position. reading. Now let's see where this takes us, really. We don't care if it's below 652, so let's go. Hey man, how you doing? I'm alright. Yeah, it's been a while since I actually used C++, so sorry if some of the syntax doesn't make much sense. Actually, I don't even know why it's giving me this. Does it want me to use square brackets then? No, but then it just gives me symbol position could not be resolved, readings could not be resolved. Yeah, but yeah, you know, just the usual programming stuff. Well, let's just keep going. I'll sort this later. And yeah, well, for now we can't really do much more since we kind of have the circuit here. It's just we just have the circuit here to do the reading. Yeah, we can then we take the max reading of this, and me too, been like 3 years since I programmed anything. Yeah, I mean, for me it's been well, what, pretty much since I took my actual programming class that I haven't really programmed much. But you know how it is. Sometimes you just gotta do what you gotta do. I will have to refresh on C++, I believe. Actually, let's see. Yeah, I should just be using the square brackets then. For some reason it's giving me as an error. This is totally valid. Symbol readings could not be resolved. Symbol position could not be resolved. Unless I need to declare them again. Oh, probably because it's in the setup, yeah. Never mind. Just me being... So I need to make it a global variable. Yeah, and now it works. Perfect. Yeah. Stuff like that is kind of... Anyway, so... And now we got a... Well... Now position plus plus, if position bigger than 20, well, in this case it would be 19 actually. Yeah, it would be if position bigger than 19. Well, equals 20, but just in case we put bigger than 19. Either way, in the eyes of the CPU, it's just gonna take one clock cycle, because instead of equal, it's gonna make it's gonna do a comparison greater or equal. So, I mean, equal would technically be a bit quicker, but we're not really aiming for speed of code here, since we kind of have we have a lot of room for slack. Anyway, if position equals 19, we are not gonna bracket this because it's just one line. Are you Susi Bakar or Basisa? I am. I mean, this is more of just an introductory project here, so making a little thing to measure some. Let me put the charge. before it runs out of battery again. I'm making a little VU meter with LEDs. You know, just to get the hang of it. Yeah, it's not abundantly clear from the title, but you know, just get a project to like show what each component does, and go working on it along the way. So if position bigger than 19, we want position to go back to 0. Great. Yes, the if chain isn't the prettiest thing, but it'll have to make do for this case. Especially since this is only going to really be, is only going to enter this chain every 20 cycles, let's say. Anyway, so I have to clean up my other breadboard. Give me a second. Because up next we are going to introduce the next part of this, and I did talk about a little bit about it on my previous video, but I suppose if this is your first time, you're not gonna have watched it, so I'll go over it again. Okay. So yeah, up next we're gonna have to use the multiplexer to, well, a demultiplexer to get to make all the LEDs work with one output. I don't really need to use one output, but just for the spirit of let's minimize the use of ports, it would be it would be a great idea, because in theory this project you could do it on any, you would be able to do this project on any Arduino really, even the Nano, which may not even have enough digital ports for what you need. So just in case, I like to minimize how many actual ports on the microcontroller I use. Well, let's just dump them all here. I'll see how many I'll need. All right. Though on my next projects, I'll probably have something more with a more goal oriented, and will be a bit clearer. So, well, so we want to make a little view meter. So I had the schematic. Yeah, just give me a second. I will cheat and use the schematic that I prepared earlier, because it would be really. No, wait, this is the one yeah, okay. Yeah, so this is the schematic that I actually did previously. This part would be the multiplexer, the demultiplexer one. So just ignore the other part. It doesn't have much relevance. Well, it was what it was before, but it doesn't have much relevance anymore for this project. So it doesn't have much relevance for this part at least. So yeah, 8 LEDs with the MOSFETs. I'll fetch them in a bit. 3, 4, 5, 6, 7, 8. There we go. I can put these LEDs away. We'll have to get one resistance and well, right, MOSFETs. too many MOSFETs. This is gonna be a mess. I should probably have done the op amps on the small breadboard and then this part on the big one, but well, let's just say constraints are good to train the soul. Right, so these follow the source gate to drain configuration. These are just 2N7000s. Really basic stuff. Well, basic enough anyway. I used them in the previous video to demonstrate the single LED. I will have to be a little bit creative here since we have so many of them. Now let's see. 1. Right, on second thought, let me move the multiplexer way into the corner, and then I'll probably have enough space for all the LEDs and MOSFETs. Yeah, space planning would be very appropriate right now. Also put them all in the same orientation so I don't get lost. I could probably also, well, bunching all the sources together wouldn't be a very good idea, but right, so 1, 2, 3, 4. And I'll do the other ones below. I actually haven't tested to see if any of these MOSFETs are working. Well, I did test one that I used previously, but it's not. Well, it's gonna be a little surprise if one of them doesn't work, even though I have a few spares. Should be enough though. Right. So. Yeah, I may want to actually, instead of doing like this, do like this, and put the LEDs over here, since the LEDs are gonna feed directly into the source. The longer one is the cathode. Yes, the longer leg is gonna be the cathode of the LED. This is pretty much standard, and I will want to. I may need to extend the pins a little bit. Oh, well, I'll just put them all in a line. Well, if I can anyway. Yeah. Let's see if I can put them close together so it will look more like a meter. Though it's looking a bit hard with the MOSFET placement. Can I reach it? No, I have to bend this one a little bit like this. But yeah, the problem with breadboards is, well, they really don't give you much flexibility in how you route stuff. Yeah, it doesn't seem to want to go down. There we go. Yeah, it doesn't give you much flexibility at all. But it's good for testing and for stuff that you can want to just disassemble later. Et voila! And now it just disconnects on the other end. I'm gonna have to just bend a little bit more. There. And, well, this is gonna look awful, but, well, if it works, I ain't complaining. It's already... Shut. Hold on. 1, 2, 3, 4, 5, 6. Yeah, I took one from over there. From my spare pile. And I could technically connect all the anodes together too, but then that would be a chore in itself. I'll probably just do better to use wires. There we go. Will this one go in? This one isn't in. There we go. Now this point. Yeah. See, I'm a bit afraid of actually just flexing this too much and breaking the leg of the LED, and then I just have a limp LED. Wouldn't really be ideal, would it? Anyways, I'm gonna have to do more of this. Wait a minute, these ones are in the same lane, so no. Well, I mean, I'm gonna join them all together in one place later, so now for this one I will... Oh, this is gonna be a mess to wire later. Now that I think about it. Way too many stray LEDs. See if I can get them all to stay in one place on this side. And there we go. Damn. Come on, don't break. Yeah. In. Good. Should be last one. Apparently I can't put them all in the same line over here. Which means to power these it will be easy. To power the other ones, oh man, not so much. Oh, damn. Yeah, this one's gonna be a problem. Probably just put him closer. Or I can just... I mean, they aren't even that expensive, really. Might as well just make it tidy. Well, at least neat, not tidy. Yes, most of the time here it is gonna be me struggling to get these things in, so I do feel like it's gonna be like this. Maybe if I just present the stuff it would be better. I don't know. Just present already pre-built stuff. I mean, I guess there isn't really much fun unless... Okay. Alright, this one's in. Somehow. And well, I guess for... Oh boy, this is gonna be a pain. I already thinking about it. Probably just use a massive amount of jumpers for this one. Yeah, just use massive amounts of jumpers. It's already gonna be a mess, so I might as well just, well, live with the fact that it's gonna be a mess. And yeah, these are I'm just peeling them away from each other. They're fresh jumpers, so yay! Can't believe I'm actually gonna have to use them like this. Anyway, well, we're gonna connect the gates from the MOSFETs to the gates of the, here it is, of well, into the outputs of the multiplexer. So I have the CD4051, which is this one. Just to, well, for full disclosure, what am I using? And yeah, right. So channel 1 is gonna be pin number 14. Which should be 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Yeah, sounds about right. Pin 4. So this is channel 1. Yeah, just gotta cram it in here. It's gonna look awful, but it can't always look pretty, can it? Pin number 2 goes here. I'm actually having to lean in to see where it's going. It isn't really a brilliant idea, this one, is it? Number 3. Oh shit, there is channel 0, isn't there? Yeah, channel 0, so just shift everything over. Right. Channel 3. Yeah. No, that's channel. Alright, 0, 1, 2, 3. Yeah. This is gonna be more wire than LED in a second. 4 goes here. I am wiring them like this just to make it easier to program later, since 1, 2. Well, this is 6 out, common 7, 5. I am wiring them like this to make it easier later. Wait, there are cables missing. Oh, just to make it easier later to know which one is which, since these lights would light up in order. I would just make an array calling each light for multiplexing. And this one, ooh, I did not think this one through. But there we go. There we go. Then I will need another jumper to make the connection from the common to some wait a minute. Yeah, I skipped one. And I will just need one of these to go from common to, or whatever pin I want, really. So let's just say pin yeah, let's just say pin 22, I guess. Unless there's something wrong with it. We are gonna run these at full power, not with PWM. Although I'm pretty sure all the digital ports on the Mega have a PWM, but correct me if I'm wrong. Right. I'm gonna need a 150 ohm resistor. And then get into cable hell. and then get into cable hell. I am not looking forward to this. Okay, well, let's get to cutting. Where are my cable cutters? I may as well cut it on camera. Just twist and cut, and well, cut and twist to take off the cover. Oh, take off the jacket, and oh man, why? Oh man, yeah, there's gonna be more cable than LED. I'm already saying it. But as long as it works, I might as well. I may just make this into an actual circuit board later. Yeah. Come on. Come on now. Yeah, I could have just changed them to also be all in the same place, but I already struggled with them once. Kind of puts me off the idea of doing it a second time. Anyway, but this is my life now. Yeah, I'm gonna do the smart ass and just connect one LED to the other. I mean, I already chose this. If you look on the screen, I already chose this sort of configuration since I only need to run one LED at a time. I just need to use on resistance, which again goes back to my goal of being efficient. Why use more components than you need to? Well, why use more components than you need to? I mean, this is a prime example of why use more components than you need to. I could probably just have gotten a LED bar. Would probably be a lot easier to. Is that the last one? 1, 2, 3, 4. Yes. Well, good. I could have just gotten an LED bar. I could just be connecting them to digital pins, but what would the fun be in that? What would the fun be in just connecting things to digital pins and programming them? Might as well get some electronics involved, put a multiplexer in there. Have some fun. Especially since, the multiplexer is gonna come in handy on a later project. And like actual handy. Since I will be doing analog multiplexing. Well, the multiplexing anyway. Just gotta plug this in here. And this goes here. And there we go. Alright, I need to connect the VDD and VE and grounds. Alright, so VE and VSS are pins 7 and 8. As much as I'd like, I can't leave the VE floating. So I'll just cut a tiny one to short both. Yeah, it's a shame that my workspace is so small, or else I'll be able to show a lot more on the screen. Well, pin 7 or 8 and 8 are the last ones over here. So just short them, jump them over to whatever GND is closer. And that should do the trick. Yeah. Huh? Get in. D. Yeah, look at this. Damn. I think I'm shorting them too short. Get in. Go. There we go. It's in. And now jumper cable. Not gonna use the red one for ground because I'm not a maniac. Ground is here, and I did calculate. In theory, this should all work with just the PC power supply. Well, the USB power supply. Then I need to connect VDD, which is pin. Yeah, a lot of stuff to look at. VDD, which is pin 16, so up top here. I do want to try. I should try to make a computer from scratch someday. Like, not a modern computer, but like one of those 6502 ones. And then I need to also short the. Yeah, sure. Wait, what did I do actually? Oh, I see. So I'm not actually plugging in the output isn't actually going here. It's going to 5 volts as well. Actually, let me turn this off so it doesn't do anything that I don't really want to do. So this goes to plus 5 volts too. Let me open up the schematic here real quick, because in my mind to save on lanes, I mean I could probably just also the inhibitor disables all channels, so it should be shorted to C table 1. Oh, please don't tell me that I didn't get it. Right, well, it disables all channels, so it should, yeah. So we're gonna use, well, the inhibitor as a sort of, as a switch, and just short X to VDD, so it would always be transmitting if there is no signal. And well, which means, let me go back to my pinout. Inhibitors number 6. Yes, it's free. I'm gonna need 3 more jumpers. Well, 4 more, because I also have A, B, and C. And we're making a wire mass, a rat's nest, if you will. Yeah, but this is gonna go in the inhibitor, and to what's the pin out here? 22, 23, 24. Yeah, I'll just use 22, 23, 24, and 25. Dude. 23, and this one goes to, looking at the schematic, well, it also says here which pin it is, doesn't it? Yeah, 6. Oh, by looking at the schematic, we see that A, B, and C are pins 9, 10, and 11. Yeah, it's a bit out of focus. Yeah, 9, 10, and 11. So A is pin 23. Gotta keep that in mind for later. Probably would be better to actually write it down right now, but yeah. Did I connect on the right one? What the hell? Oh no, I didn't. Right, B is 24. And C is 25. There we go. All hooked up. Now we need to program what do we want this to do. So we go back to our little rest nest here. Let's see. Yeah, this can probably show the LEDs better. I'll probably tie this down afterwards. Anyways, what we want this to do? Let's go back to the workspace. All right, so. So after the if, we end. Well, I guess we could do after 19 int max. No, actually at the beginning of each cycle. No. Right, let me think this through again. I could put this all into a for loop. I equals, yeah, but then it would turn the I equals 1, I smaller than 20. This probably, yeah, right, it's this. I plus plus, because we want to add 1 every time. We want to stop at 20. Right, I forgot to declare this. There we go. So if reading bigger than 652, we want the average of yeah, we want the average of 20 readings, which with them being all above 652. And in this case, we can pretty much just delete the, if we do it like this, we can pretty much just delete the array, but we'll keep it here just commented out just in case we actually need it. And then the position pointer also becomes obsolete. Well, yeah, so serial, we'll keep it printing just for debugging, but right, delay 10. Alright, so for int is okay, and log read, serial println reading, delay 10, if reading bigger than 652, and I will add another integer here, max. Oh no, wait, I could declare it at the beginning and then of the loop, and then just int max equals 0. So this way we have a self-resetting variable. So if reading equals 652 and reading smaller than max. No, if reading bigger than 652 and reading bigger than max, we could probably just boil it down, make x. Yeah, we could just boil it down, make max 652, which is the minimum, and then just if reading bigger than max, just do whatever we want, which would be well, store it as a, let me store it as a global variable, int peak. So we will start it as a global variable named peak. Peak equals, well, reading, and then we can end this. Yeah, I think we can just pretty much delete everything here. Delete these two pointers. There we go. Align the brackets, because why not? Keep your stuff tidy. I will comment this. I will comment everything here, even if I'm commenting right now. But I will rigorously comment it later. Actually, let me tidy this up. Right. There we go. This if is closed, this for is closed. Then, well, we want to get the peak reading to calculate how much, which LEDs are going to light up. So, well, we have 8 LEDs, so you can convert this to an 8-bit value, really. So convert to an 8-bit value, we would have to resize it to 256. There was a function in to resize, wasn't there? Yeah, I feel like I remember something to resize. Well, to change the boundaries, but apparently not. Well, so we're gonna have to do it manually. So we have which max is 652, which means, well, we can classify 652 as a new zero, so peak equals peak minus 652. But then we still have what? But instead of 256 value, we still have 371 values. So divide by 371, multiply by 256, but then we go into the realm of well, floating point. So yeah, I guess we're gonna have to pass this to floating point. Peak float, peak minus 6, oh, int peak float, and then have to truncate it back to integer. Peak minus 652 times 256 times divided by 371. And yeah, I think with this we should be good. We have we will get the new peak except in floating point. So then later I will create another variable. But we can all simplify this later, which would be Do I need to cast? I guess not. Well, new peak is going to be, well, just peak float. Actually, I should change this to, no, not double. I don't want to use double, just float, yeah. So float, and then new peak. It's gonna be a peak float. And there we go. Now we have a now we should have a number between, well, 0 and 256. As for our measurements, I mean, if we want to make sure, just there, and like this, we are certain that it will have will be 8 bits. Now, I will do a little hack here, since I don't want to actually calculate the... Wait, that wouldn't actually work, would it? It might work actually. I'm thinking of instead of reading the whole number and then having to convert it to a string of well, a binary array. Instead of doing that, I could just get the highest one in the binary format and just use it as the peak. So we have 8 bits. I want a bitwise. Will I have to use assembly for this? I might have to use assembly for this, but I think it might be a little bit too much. Oh, hold on. No, I can actually just address bits individually. So, well, 4. Yeah, I will have to make another integer. Int high bit. So for I equals int I equals 1. I smaller than 8 because we're going from 0 to 7. I plus plus, since we want to add to increment, we will go through single increments. Right, so if bit no bit no, I should be 0, should start from 0, yeah. Actually, no, let's do I starts from 7 since yeah, if I starts from 7, we can have I bigger -1, bigger or equal to 0, because I don't really want to go into negatives, and I minus minus. Same thing except with decrements. So if bit I equals 1, I want to write why is this not yeah, I want to write I to high bit I, and then we don't really need to chase after it later, and we also minimize because we are going to break this. I'm just very So if I break this, it will break both cycles, or yeah, it should break both cycles. And so yeah. So if bit I equals to 1, we're gonna write high bit and it's gonna break. Or it should break everything. So let's see. Yeah, let's just let's comment this one out and see if the serial, if I put a serial println here, what will it do? I'm actually kind of curious to see what happens with a high bit. Right. So plug it in and upload the new file, or else it'll just start chooching out the big numbers, doesn't it? Close this and add a new serial port connected. Yeah, it's just chooching out big numbers. I don't have anything playing at the moment, so you can't really see if there's a big variation, but well, I mean there is something at least. So yeah, let's upload the new sketch and see what happens. Yeah, everything's fine. 0 0 0 0 0 0, as it should be expected really, since we are, well, since there isn't anything pumping through. But let me get my iPod back and we'll check if this actually changes, if there is an input. Now with some Nico hacker, for those who are well acquainted. Just gonna go out and say I am not sponsored by anyone, so I mean, why would someone sponsor a channel with 20 subscribers? But yeah, just full disclosure, I guess. I can't actually read what's going on since yeah, actually I will probably want to where is the probe? Here. Actually want to see what's the output. Where did the jumper go that I was using to measure? I'll just use this one. No, hold on. It's here. Yeah, we do have a waveform. Oh, which is good. Means nothing broke. While we were fiddling about. But, well, something is... Oh, what is this? Oh, hold on. I did a little whoopsie here. Right, so I made this new peak, but if... wait a minute. New peak... I think it works like this, doesn't it? Does it work like this? Syntax error. How do I... Yeah, how do I use the bit? This isn't really... That isn't really brilliant. Computes the value of the specified bit. Bit whose value to compare doesn't really make much sense. Yeah, I may have to use actually. Oh, hold on. Into bit. Yeah, I can write a bit. Bit read, yeah. Right, so if bit read, what's another? So x will be the variable, so high bit, new peak, comma I is equal to 1, great. Yeah, now I need to re-upload this, yes. Good. So on the serial monitor we still got zeros, but if we turn on the music, we get a blank screen. Oh, alright. So we hit play, and we just get zeros. Although there is something playing. Yeah, high bit was declared here. Maybe the break isn't working as I intended. Right, so I'm gonna have to think this one a little bit more. The break won't work. It's just rewriting indefinitely. If bit read, the new peak I equals 1. High bit equals I, and then might just add a int I already have an int. Yeah, I already have something named peak. So bpk, which would be bit peak, equals 0. I'm just gonna add it here, and bpk equals 0. High bit I break, high bit I, bpk equals 1. Just to get this working. Oh, right. bpk equals to 1 break. Yeah, all right. Now it should be rolling. Let's see. And serial monitor. Is anything playing? In theory, yes. Let me print new peak for a second. What do we get? 0. Oh, it's definitely not receiving 0, is it? Because if we go back up, where is it? Here. And get the reading, too. Or is it receiving 0? No, it's definitely not receiving 0. But every time it goes, it gets a 0. So there's something over here that's making it lose the stuff. Well, guys, we're gonna have to just serial code everything to monitor. I will put a serial code here for peak. A serial. Println. Because we got some debugging to do, I guess. One warning. Where? High bit set but not used. Oh, hold on. Let me. Yeah. So peak is going. Peak float. Okay, there it is. So something's going on so that peak float doesn't work. Yeah, it's definitely peak float. It's definitely peak float. So yeah, well, I mean peak minus 652 times this should be So I just take this off, what happens? Because it could just be on the... Oh, we're getting something, yeah. Yeah, we're definitely getting something. But I just can't resize it to fit on the 256. I think there was a way to resize the... Yeah, I do remember there was a function to resize. Guess I'm gonna have to check the Arduino reference. Well, let's see. I'll let you guys join in for the ride. So it was... Huh, where is it? Floating point constants, integer constant. No, I don't want constants. Would it be constrained? Shit. It's been a while, really. Oh, yeah, constrain a number to be within a range. Lower end of the range, upper end of the range. Yeah. So returns x if it's between, x if it's less than a. But this isn't what I want. There was actually a function to... I remember there was a map. Was it map? Oh yeah, map. Yeah, these weird names. I mean, it makes sense, but so I can just, instead of just writing, converting to float and whatever, I can just from here. Map. How was it? Yeah, so just byte new peak. Map. Peak. From. So from low from high to low to high. So from 652. Six, 5, 2, 10, 23 to 0, 255, and that should, and I would do the trick. So we can just forget this. Can just forget this, and verify. There is one warning, which is the high bit. Right, so then if we go on the serial monitor, yeah, it's working as intended. So let's see high bit then. And in this case, we should be getting now 6, 5, 6, 6, 6, 6, 5, 6, 6, 6, 6, 6. Is it playing anything? Yeah. Now the numbers really are crunchy too. Yeah, now it's going all over the place. If I lower the volume, it goes to 6. It goes to 6. 7. Well, part of it is fixed. But why? I will have to probably print a new peak again. Actually, what happens if I pause? Which shouldn't have any 6s. It just goes to 6. Which means the map isn't really going from 652, is it? Because the 652 should be the minimum. Yeah, once I press play again, it just and turn up the volume a bit. It goes 7. Yeah, it's weird, very weird. Oh, it's definitely gonna write 7, but then it should. Why is this break doing here? Let's see. Yeah, it's still getting only 6s. Oh, we're getting a 2 every now and then. I mean, there is music playing, so if we pause, it just goes to 6. So the resize isn't exactly correct, I think. Though. So yeah, map value from low from high to low to high. Oh, anyways, so all right. This is all stuff that can be that can be addressed later. Although I would like to actually address it right now. Why is the... I mean, it would make sense if it's the maximum that it would be. Unless I... What if it's... what if I do this? Still sixes. Alright, so we're gonna have to debug it again. What's going on here? Why is it so high if it's just... If supposedly there's nothing playing? Is there that much noise? Guess I'm gonna have to probe it again. Right. Yo. Yeah, I mean, it's the music's paused. This is at 3.1. Let me just for sanity. What is going on? Why is it at 3.0 volts now? Why is it resting at 3.0? Is it noise? I mean, that's a lot of noise if it is. Because it's just going from 2.4 to 3.0. Or is that just how it's gonna be? Hold on, I'll decrease the gain a notch. Yeah, now it's back to 2.69. Nice. If I put something to play, I can just bump up the volume here. Yeah. Let's just work a bit with the jank. But now if we pause, we get fives. Oh, I mean, I guess you can't really have a perfectly quiet audio, can you? Also, this is on a linear scale, so logarithmic would probably be a lot lower. Anywho, yeah, so let's make this thing light up then, like a Christmas tree. Christmas in August, because it's not even July anymore. And, well, right, what do we have here then? Right, I'm gonna have to set a few more outputs. So I want, what? 22, 23, 24, and 25. And 22 is going to be... What did I connect it to again? 22 is the purple. Yes, it's connected to number 6, which is the inhibitor. Right, pin mode 23. output. Oh, this is going to. Wait, what? Oh, is my camera? I think I lost my camera. No, it's still going, isn't it? No, I lost it. Yeah. Probably overheating myself. My poor cell phone. My poor cell phone. That I can. Well, I guess we're gonna have to go without the camera for the rest of the stream. Without the overhead camera, I should really get a proper one. Anyhow, Linux A. I could just copy and paste this really. Save some time. C B 4 5. Right, so oh, they should already be powered up. So once we have the the 3-pin set up, we want to put in I will make an array for the LEDs, which is just kind of 7. All right. An array of 8 LEDs, just to be easier to call. I could probably make a function for this. Would probably make it a lot simpler too in the long run, but so as long as the inhibitor should mean that it's on, except when it. So the inhibitor should well, it's not a NOT gate, so as long as it's connected to 0, it should be transmitting. So well, I'll probably do but make digital out, digital write. 23 0 or 1, because I don't want it to be doing anything right away. Well, enables in this context. Then I will want to do a I could probably get away with a for cycle for I equals 1, I smaller than, well, less or equal than what? High bit, I plus plus, we will want to, well, every cycle we start lighting up one LED from the bottom to the top. So, I mean, in this case, why did I make the LED 8? Just wait a minute, actually. Good to encode yeah, I'll probably make a function for this to convert from from the 0 to 8 into a, well, no, I'll just make it normally. So alright, so 4. Then again. Analog. Right, no, digital right. Actually, no, hold on. LED, well, LED. We'll make this. And we'll see in a second what I'm doing. I should probably have deleted beforehand. Oh, you know what? Six, 8. Right, so 1, 3, 2, 3. This probably isn't the most efficient way. I could probably do an assembly hack. But yeah, that could actually be a pretty good thing to go come back to at a later date. Wow. What am I doing? There should be a 0, of course. And yeah, this is pretty stupid, but I will admit this is pretty stupid, but I mean, and incredibly wasteful, because it's all going to memory. Right, so well, for I equals to 1, I less than high bit, I plus plus, I'm gonna make especially since I can't really call this, can I? Can I make a... No, that would be too complicated. An array of arrays. I mean, I could probably. An array of arrays. It will kind of end up in the same place though. Well, let me try something else then. Yeah, this could work actually. 8. Instead of addressing by... Right, so 0 bit is gonna be, well, 0, 1, 0, 1, 0, 1, 0, 1. This one's gonna be 0, 0, 0, 1, 0, 0, 1, 0, 0, 1. Right? No, this is 9. Right. 0, 0, 0, 1, 0, 1, 0, 1, 1. Right. Now we're going. Zero, zero, zero. No, hold on. There we go. Yeah. Yeah. Now what I'm gonna do is digital right. I shouldn't really name this A, B, C. And actually I should check first. Is it select A? Oh, I can't believe I didn't get the tables. Sure seems to be like that. No, okay, but it's yeah, A is the least significant digit. Good. So digital right, 23, 23, yes. A. AI. What do you mean symbol I could not be resolved? Should I put this? But then this will just become syntax error. Oh, because this is, I haven't declared this. Right, good. So digital right 23 AI. Same thing with B and C. No, B, C, 5, 4. And all right. I'll put this in here so it enables before writing to every second and disables. Digital right, then digital right. Then I just 23 0 disables inhibitor. And let me check it out. There are no errors. Good, that's good. But the LEDs don't seem to be going. Oh, did I mix up the polarity? Oh God, please tell me I didn't. Let me take one out to test. Oh damn. Oh no. What an awful predicament. Yeah. How is yeah, we might be able to get the picture again by the end. What a horrible predicament. Because now I need to navigate through this rat's nest. No, did I? Oh right, I didn't. Oh man. Yeah, no, cut the power here. I got a very crucial thing, which is just to connect all the MOSFETs to ground. I probably just use jumpers for this too. Right. So connect everything to ground. Oh, jeez. Really does you in good, doesn't it? When you realize you forgot to connect like half of the circuit, because then there is no current flowing if it's not connected to ground. And the rest just gets bigger and bigger and bigger. Yeah, I'll see if I can get the video feed going by the end. Unfortunately, it kind of, went kaput. Anyway. Well, let's see if it works. Looks like the polarity is still wrong. Weird. Many mistakes, very little actually working. So what is going on? Oh, it's not connected to power. There we go. Yeah, I'm sorry for the lack of video feed again, once again. But two of them are working, which probably means that the others are reverse polarity. Hold on, this one, where does this one go? Here. Alright, yeah. I also reversed the polarity of most of them. Yeah, I guess I'm a bit of a klutz, though. There we go. Yes, I managed to reverse the polarity of most of them. Wow. I shouldn't be messing with this one with the power on. Alright. Damn. It's tight here. Holy. Come on, get in, get in, get in. Please. Do it for me. Ah, no. It's out. Yes, please bear with me for a second. This is being a pain. Oh, God. I think this lag is too mangled. I'll just get a fresh one. Right, let's see then. There we go. This one's in. Now I just need to change the other ones. There we go. If you plug it in, it should. Weird. Oh man. Yeah, it's getting almost no power. And for some reason the red LED is just lit up all the time. What is going on here? Oh, Jesus Christ. I don't even want to look. Right, let's see if I can get the feedback on so you can get an idea of what's going on. Yeah, just give me a second. The phone's starting up. But meanwhile, why did they all just... Yeah, this is weird. They shouldn't all be lit up like this, should they? No. No, because high bit is supposed to be 5, isn't it? Probably too fast, that it's so fast that it doesn't make a difference. Well, anyway, yeah. There we go. We should get the feedback in a second. In Jiffy. Right, RideCam crashed. Right, and we are back. Good. So here it is, my rat's nest. I have a slight feeling that the problem of the LEDs all being lit up at the same time is that I'm not giving too much time for the multiplexer. I'm not giving enough time between runs. So if I put a delay of like, yeah, let's just put a delay of, I don't know, what, 50, 100 milliseconds? Delay is supposed to be in milliseconds, right? Yeah, delay is milliseconds. Alright, so let's just put a delay of 100 milliseconds. See what happens. But well, it is working. It's not so much pretty, but it's working. Nah, 100 milliseconds may not be enough either. Although they are all lighting up, even though one of them, even though they shouldn't. Where am I disconnecting? I unplug the gate for this one. What happens? Huh. 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 Yeah, this is acting up a little bit weird. Debugging this was gonna be a pain. I'll probably do better to tidy this up. Oh, hold on. I think something's wrong here. Oh, this one isn't connected to anything. Oh, so that's what was going on. Weird. No, it doesn't. Nothing works. We're getting, huh? Something. There's something wrong here. Well, I mean, we are getting the LEDs to work, but it's not really what I was expecting. If I increase the delay, maybe. Oh, high bit is still. So, for example, the red LED shouldn't be lighting up for now. Oh, now it should, but not always. I do have it connected to its respective port, don't I? It should be channel 7, which. Yeah. No, hold on. This one's going into channel 5. I mean, it still doesn't matter because it's not really what I was planning on. Would it be this? If I just take this off and do separately, well. First of all, I think this is supposed to be I equals to 0, so. Let's see if this works. Test one by one individually. No, everything just stays lit up. I'm willing to bet that there is a short somewhere in here. which wouldn't come as much of a surprise really. Oh, wait. Yeah, I'm willing to bet there is a short somewhere around here. I mean, oh, these are connected to ground, but they should be. Alternatively... Oh. Well, alternatively, I don't really have much of an idea. Although... Unless... Oh. Yeah, that could be it actually. I'm gonna have to do some... I have a slight feeling that this might be what's wrong, but if it is, I'm gonna have to... If it is, I can't resolve anything right now. I'll be honest. But... Well... It's turned off now, so we shouldn't have... the impedance shouldn't be too high. So... Gonna test VDD against all of the outputs. I have a slight feeling that if the chip is burned, it's gonna be awful. Alright, so VDD is the one over there. So turn on the backlight so it'll be easier to see from home. Yeah, that one was... Hold on, what? No, this one's open. This one is open. What's the resistance though? No, 8 mega ohms. It's not shorted. It's definitely not shorted. So, what's going on? What is going on? Yeah, it'd probably do good to tidy this up with a smaller cable, which I might actually just do. Well, the rest of the circuit works fine. It's just this that is giving me issues. It's connected to plus, yeah, VDD. Then 7, yeah. Because I mean, if I just turn on and connect the Arduino and just rip out these 3 pins, what happens? Yeah, it just stays on, stays lit. Although it should be turning off. Yeah, I'll probably have to do some more debugging on this. Probably tidy up the circuits too. So, well, I guess that's it for today. Unfortunately, I couldn't finish it, but it's taking shape. And well, although the shape isn't very good right now, it should be done by the next. There's always a next week. And well, I guess I'll have it ready to go by then. But I mean, I said last time that I said that there's always next week, I kind of disappeared for a month, but I won't let it repeat this time around. I swear. So yes, I guess that's it for today. Thank you very much for watching. If you liked, please leave a like, and or if you really liked, subscribe to my channel so you receive updates, and also to my Twitter for any news. And well, I'll see you. If you're here for the electronics, I'll see you next Sunday. If you're not here for electronics, if you're not here just for electronics, well, I'll see you next time. I don't know when I will be able to do a game stream this week. I'm particularly busy, but yeah, we'll see you next time.